Okay, in this video we're going to go over a couple of trig concepts. This is from question 2 on our practice exam. Well, it's supposed to be an easy question. It's number 2. It's only worth 5 points. So sine theta equals root 5 over 3. Theta is acute. Theta here is the angle. And if you notice, question A and B is not asking us to find the angle. We're never asked to find the angle. If we were expected to find theta, we would need a calculator for this one, because root 5 over 3 is not from one of our special triangles like 30, 60, 90, or 45, 45, 90. So there's no way we're expected to know what that angle is without a calculator. But they're not asking us for the angle. They're asking us for a different ratio. In part A, they're asking us for cosine theta, and then in part B, cosine 2 theta. So sine theta equals root 5 over 3. I think the most concrete way to imagine this is to draw the coordinate plane. It tells us that theta is acute. Acute angles are between 0 and 90. And so that means I know that the angle is in quadrant 1. And I don't need to know how big the angle is. I'm just drawing a sketch of this. I could create a triangle, right triangle, that goes to the x-axis. And I know that sine is opposite over hypotenuse. So if theta is here, this angle that I don't know, I can label the side opposite it root 5, and I can label the hypotenuse 3. This helps me see that in order to get the other side of this right triangle, I can use Pythagorean theorem. So root 5 squared plus b squared equals 3 squared. I need the other side because I'm going to try to find the cosine of theta. And cosine is adjacent over hypotenuse, so I need to get that adjacent side. Square root of 5 squared is 5, plus b squared. 3 squared is 9. Subtract 5 from both sides, and b squared is 4. Square root, and b is 2. I don't need to consider the negative because I know I'm over here in quadrant 1 where x is positive. So the cosine of theta is just 2 over 3. It's a ratio, just like the sine of theta was a ratio. So cosine theta equals 2 over 3, adjacent over hypotenuse. Cosine 2 theta, I'm not going to be able to get from this picture. I've said it many times that 2 theta does not mean that we are going to double the angle, because we don't know the angle. We don't have any skills for finding 2 theta other than cosine 2 theta being in our formula booklet, that we have some identities that tell us cosine 2 theta is equivalent to some other expressions. There's 3 options we could use. I'll use the first one from the formula booklet, which says cosine 2 theta is equal to cosine squared theta minus sine squared theta. And you might think you don't have enough information to evaluate these either, but you need to appreciate that cosine squared theta actually means cosine theta, whatever that quantity is, squared. They just put the squared inside so that it doesn't look like the theta is being squared. In fact, it is the cosine of theta that's being squared. And this means the sine of theta quantity squared. And in this case, I have the cosine of theta. I just found it. And you would get follow-through points here for using any answer from part A that you had, as long as you used it correctly in this formula. Cosine of theta is 2/3, and I'm squaring it. Sine of theta is root 5 over 3, and I'm squaring it. This is non-calculator, so we're expected to be able to simplify this all the way down without a calculator. 2/3 to the second power means 2 times 2 and 3 times 3, so 4/9. Root 5 over 3 squared is 5 over 9. And so when I simplify this, negative 1 over 9 is the final ratio for the cosine 2 theta in this example. And that's all.